Hey guys, so today we're going to go over a example of single cycle data path. So let's go ahead and pull this up right here. So in this problem, what we're going to be doing is we're going to be using this we're going to be implementing this LWS instruction, and we're going to see how the data path control system will work in single cycle data path. Okay, and what does LWS do? So initially we need to figure that out. Over here, there's a little example of how it should be working. So what it should do is it should get RS value multiplied by 4, added with RT, and then get the memory. It's going to get something from the memory and then load it in RD. Okay, and that is very similar to the normal load word instruction where we are loading a value and we're getting something from the memory and then putting it on another register, except for the only difference is we're going to be multiplying RS by 4 and we're going to be adding it with RT where we have two register value except for one. And you can see also over here a simple example of how it should operate. So let's go ahead and say our RS is A1 and our RT is A0. Our RS is 10 and RT is 1000. So when we multiply our S by 4 and add it with RT, we should get something like 1040. Okay, and well, let's go ahead and see how to implement that in single cycle data path. So I went ahead and wrote this down up top right here, LWS. This is our instruction. So initially, you want to go ahead and say figure out what all the read address 1, read address 2, and write address registers are. So we know this is RS. A simple way to remember this is the first one is going to be RS, second one is going to be RT, and third one is going to be RD right here. And we're going to be using muxes to figure out what is going to go where. And sometime on the instruction, you're not going to have a value for RS, RD, or RT. So don't worry about it. We're going to go ahead and put X's for those scenario. However, in this instruction, we do have RS, RT, RD. So we're going to be using all three of these addresses line. So let's go ahead and see what is going on right here. So over here, read data 1, we're just passing RS to LU, but we don't want to do that. We know that RS is getting multiplied by 4 from this instruction right here where it says RS is multiplied by 4, right? So let's go ahead and take this, where we're going to go ahead and cross this off. Let's go ahead and make this a little bit clearer. Go ahead and cross this off because we don't necessarily want this. So we're going to go ahead and sign extend it. We're going to go ahead and shift it left 2 because we know there's a little example of it right here where this would be either shifting it by 2-bit left or which is equivalent to multiplied by 4. And in this instruction, we can see that we want to multiply it by 4. You can also do this by using adder alias, which is very inefficient and very expensive in this case. So I don't recommend you to do that. We can simply do it just by using shift left 2 data path. So this is going to be shift left 2. Let's go ahead and put this to shift. Okay. Shift L, and then let's go ahead and put 2. Oh, this 2 can use a little bit more work. So let me go ahead and make this better. Shift left 2, which is equivalent to multiply by 4. We're going to take the output of this and then put it in a mux. Because the reason why we're using mux rather than just putting this value to the first ALU input is because sometime for a normal instruction, we're not necessarily multiplying RS by 4. So in that scenario, we don't want it to be messing around. We don't want this input to be get messed up by multiplied by 4 every single time. So we're just going to go ahead and use a mux, and every single time we are using LWS, we're going to go ahead and use this mux to go ahead and get the value of shift left 2, which is equivalent to multiplied by 4. And also let's go ahead and initialize a control unit for that because we will need somewhere to get the max value coming from. Okay, so this is going to go right here, and let's go ahead and call this where LWS, which is going to be 1 whenever LWS get executed. So what happens to the output of this mux? This output of this mux is going to go to the first input of this ALU right here. Let's go ahead and add that. So as you can see, this is going to be the first input of ALU. Okay, So what is this doing? So it's going to go ahead and multiply 4 to the RS and go ahead and put that all the way up here as the first input for ALU. And we know that ALU off for this instruction is going to be 0, 0, which is very similar to load word. And we know that ALU control for load word is add. So over here in the ALU, we're going to be adding. Let's go ahead and put 0, 0 for ALU up. So over here we should be adding. So after multiplied by 4 RS by 4 and then taking the RT value right here in the ALU right here, we're going to be adding these two values. Okay, and then after that we're going to go ahead and put this in the memory, data memory, and then we're going to go ahead and read the value from that and then put this, and we're going to use this mux to get a value that will go to the register destination from the memory. Okay. Okay, so how about all these control units? What are these going to be? So let's go ahead and define that. We know that ALU is already 0, 0. How about the register destination? Usually in load word register destination, you want RT, but in this case, we want RD because RD is the register destination. And in the mux, you can see that RD is 1. So we're going to go ahead and put RD1. How about for register write? We know register write is 1 whenever we are writing some kind of data. So in this case, we are writing something, so register write is going to be 1. As for ALU SRC, we know that there is no integer immediate value right here. So as you can see, we're doing RS, RT, RD. There's no immediate value, so we don't need, in this case, we do not need this right here. We actually need the RT read data value as our ALU second input. So this we want to be 0. Okay. All right. How about memory write? Okay, we know memory write is whenever we're writing in the memory, but in this case, in LWS case, we're not writing in the memory, we're rather reading from the memory. So this memory read is gonna be 1 because we want to read from the memory. How about memory write is gonna be 0. Okay, that brings us to our next question. Memory, mem to register. What do we want for that? We know that ALU is coming out, the ALU value is coming out right here, and then putting it on the 0, on the mux. And then we know that whenever we read from the memory, this will be 1 right here. This will be 1 right here. Okay. Uh, this value right here is going to be simply RS times 4 plus RT. However, we want the memory value of that. We want the value from the memory for that. So we want to want 1 right here. So mem to register is going to be 1. Okay. So this will be writing on the register on the RD location. And then after that, now we have these two left. We have branch, we have jump. We're not branching anything. LWS does not branch anything. So branch is going to be 0. So as jump, we're not jumping anywhere. So it's going to be 0. Okay, so this is basically the implementation of LWS. So let's go ahead and see what each, let's go ahead and go step by step and see what it does. So in the PC, we're going to go ahead and pass the instruction. We're going to go ahead and go to the next address right here, but that's on a later cycle. Then after that, over here we're going to be decoding. We're going to be this is the instruction decoding phase where we're going to go ahead and pass it to the control unit, pass the function operation to the control unit. In this case, the function operation is going to be, our opcode is going to be 101100, which is right here in the middle after R type on the second paragraph. Okay, and then after that, control unit is going to decide what control unit value is going to be for each of these. In the register file, we're going to be reading all these RS, RT, RD. We're going to be multiplying it in the shift left 2, and then we're going to go ahead and add it to RT. And then after that, after all that, we're going to go to the data memory, and then we're going to go ahead and read for the memory, and then the value for that is going to get passed to the register destination, which is exactly what we want for load word S, LWS. So this is how you basically implement a simple something that is not on your green sheet or anywhere. Okay, thank you guys.